Hello, and thank you for joining us for today's webinar, Robotics and the Future of Food Processing. The discussion will last approximately 50 minutes, followed by 10 minutes of question and answer. Our presenters are Brandon Harrison and Heath Clifton. Brandon Harrison serves as Engineering Manager of Staübli Robotics North America, a world leader in industrial automation. He joined Staübli in 2011 as an application engineer and has been involved in hundreds of robotic integrations from conception to installation within a wide range of industries and fields, including food processing. Today, Brandon manages a team of application, control, and mechanical engineers, and he is Staübli's primary technical contact for all food OEM development. Heath Clifton serves as Engineering and Controls Manager for EnSight Solutions. Prior to joining EnSight in 2019, he spent 15 years working with robotics, controls, and automation. He has extensive experience in project planning, integration, implementation, and maintenance. He currently leads a team of mechanical, electrical, and controls engineers and oversees EnSight's UL-listed panel shop. Committed to providing customers with the best solution possible, Heath works closely with EnSight's sales team on application development. Thank you, Brandon and Heath, for joining us. Today, we will be covering questions we frequently encounter related to robotics and food processing. If at any time during our presentation you have a question, please submit via the Questions tab in the GoToWebinar toolbar, and we will respond at the end of our discussion. Or if we do not get to your question, Brandon or Heath will respond to you via email. We will also have 2 polling questions to help facilitate discussion. You will be notified when the polling question is made available. And with that, let's move on to our first question. So Brandon, why are processors looking to robotics now more than ever?
Well, I guess I should first take the time to thank you, Luke and Heath, for having Staübli and myself be a part of this conversation. We're definitely privileged, and we're happy to be in a partnership with EnSight, so thank you. So why are processors looking to robotics now more than ever? I think it starts with capabilities, right? I think robots haven't always been capable to be in the processing side of the food environment. They've been in packaging for a while now, and just in the last few years, they've started moving into the processing side, and it starts with capability. So it's things like the hygienic design of the robot. It's the hygienic design of the whole machine itself, right? It's not just the robot, but managing the bacteria, managing the retention areas, overpressuring the inside of the arm to protect against microorganisms, and it's obviously the washability. Cleaning is an essential part of the process and to guarantee food quality of any sorts. And now with robots being able to withstand pH ranges from 2 to 12, we're able to wash it with some pretty caustic stuff and still have it in this food environment. We now have food grade oils with no reduction of performance. And the portfolio of robots that are being offered is pretty vast now. It used to be 1 or 2 robots that could work in that type of environment, but nowadays it's, we have basically the whole product line that is available for the HE or human environments. So besides that, if I think bigger picture, right, if I just don't look at the robot itself, I think big picture, there's always been the stigma or a fear factor of having robots in this type of environment. And I think that's slowly going away. Like I mentioned, it's been in packaging for a while, but as we make these advancements in technology, it's getting better and better. And, it only takes a couple robots to do very well to kind of satisfy that stigma, and then everybody else is going to start picking up on it and running with it. It's already been done in Europe, and it's slowly happening in the US now. So that's what I'm seeing on my side.
So from an integrator side, kind of like Brandon touched on, the capabilities of the robots, the things that the technology advancements they've had where they can be put in wash down environments. They don't have to be bagged. They don't have to just be, wiped down. Staübli has really put out a great robot. They look at a lot of sanitation design that we incorporate into our own designs from an integrator side, trying to help our customers understand that there's not going to be harborage points, there's not going to be flat surfaces where water can sit on, but really, so why are they looking at it now? I think obviously with a lot of the the COVID-19 things going on. They're looking for places they can space people apart more. You know, standing right next to each other in food plants is something we see all day long. And I know people they're trying to space them out, make them more safe. You know, they're also looking for places where there's a lot of repetitive work. You know, obviously, like Brandon said, the packaging, palletizing, cartoning, things like that have already kind of been taken care of. There's lots of opportunities on the primary side where repetitive motion can be taken out, now that we have the technology to do it. And also, with more robots being out there to use, you get a better price point on them as well. You get a better ROI. As jobs become harder to fill. I know whenever we go to food plants, there's always signs outside, looking for, operators to come in and work. As the cost goes up to pay them to get people to come in, technology, gets better and the price on robots and integrating a whole system goes down, that ROI just starts to make more sense. I really feel like we're at a point now where if people come in, they've got an operator, one or two operators doing a task, that we feel like we could find a robot that could do that task for them. Not necessarily so they can get rid of them. I hear it all the time. It's very critical to have people in food processing, but they need to put them in places where it's not just repetitive tasks, where something a robot can't do today. There's just a lot of great opportunities that people need to look for now.
All right, thanks, Brandon and Heath. Let's go to our next question. Heath, I believe this one's for you to field initially. What are some ways processors can evaluate if robotics is a good fit for their application and operations?
Kind of like I just touched on, everybody is always looking at the bottom line. The first thing they can look at is the ROI. Does it make sense? A lot of people have a 2-year payback. And I really feel with EnSight, how we partnered with Staübli, that we can offer an ROI on robots that would be less than a 2-year payback. It just depends on, like Brandon said, if they're comfortable putting robots in. It only, like he said, it just kind of takes that one robot to go in to really prove that it will work to start evaluating other opportunities for it. The other things they need to look at too is what's the environment it's going in. We have the HE robot is full wash down. Everything else that we go with it, the stand, the rest of it is something that EnSight fabricates ourselves. Everything's all stainless steel, so it'll be perfect for that the wash down environment. Just looking at cold environments, hot environments, places you have high turnover rates. That's one of the easiest ways to look at as well. There's plenty of places that you could evaluate if robots is good. The other great thing, not just with robots, but the inspection cameras that have come along. Some of the deep learning stuff that they're doing now that robots can use to decide if a part is good or bad. Just the inspection process that it can do now is just amazing. And if it's something they haven't looked at before, that would definitely be a great fit to evaluate robotics in their plan as well. So, Brandon, do you have any thoughts on that?
Yeah, Heath, I would agree with a lot of what you said there. I mean, the ROI is definitely where you start the conversation. And like you mentioned, getting people out of the cold environments, getting people out of the tasks that are redundant and have a lot of ergonomic issues and don't have very good upkeep because you can't keep people in that job because nobody wants to do it. I mean, that's where you start. You start with a need. You start with a problem that needs to be solved some way, right? And really only you as an end user can answer that question of where it should be a good fit, right? And then you just have to ask a professional after that. Ask somebody like EnSight or ask somebody like Staübli. There's a bunch else on the market, right? But you got to ask to see if it makes sense at that point. And then we'll show you the ROIs. We'll show you what it takes to make something fit into that void. And then we see if it makes sense for you, right? The first step is get linked up with a good integrator that is familiar with the industry, right? I mean, you have to have somebody that knows whatever industry you're in. If you're in bakery or if you're in poultry or if you're in red meats, whatever it is, there's different criteria for each type of industry. So finding somebody that knows that industry is the first step. And then we can do a lot of things in the pre-sales support role to make it easy for you to make a good assessment whether this is a slam dunk or not, right? We could do 3D simulations showing that what the line would look like, some proposed cycle times. We could even do some live testing, which I think in food is paramount. I mean, every food application that we've done has required not just some simulation, not just some theoretical numbers, but has required some live testing, functionality of the tool, functionalities of the robots, functionalities of the grippers or the suction cups or whatever you're using, just to make sure that it's actually going to do what we think it's going to do. I mean, we can do all the analysis we want in simulation. We can put in all the theoretical mass numbers and know what we think it's going to do to the robot at a certain cycle time or something like this. But until we do it on a real robot and with a real product and see how that product reacts to being moved that quickly, that's when we really know if it's going to work right now. So that's where I would start. Just ask the right people. I know it's a very simplified way to put it, but I think that's where you have to start. And maybe that brings us to our first polling question.
Actually, Brandon, before you finish, I wanted to kind of jump in and touch on that too. Something else that we see that maybe people don't look at a bunch when they're trying to evaluate if robots are good for what they're doing, is to look at the sanitary side. Are there places where you have high contamination because people are touching the product, or they have to move it around? Robots, don't bring any germs in with them. It's a great opportunity to kind of get rid of that place where you can contaminate product. Robots can come in and kind of pick that up where people, aren't needed where they're currently be using now. So thank you for letting me jump in.
Yeah, that's a good point.
Michelle, yeah, and everyone, here's our first polling question. How much do you agree with the following statement? We are comfortable implementing a robotic solution. Strongly agree, either agree or disagree or strongly disagree. And so once everybody has a chance to answer, we'll move on.
So Luke, we don't get to vote, right? Is that what you're saying?
Well, you can. I'll just mute you from being able to actually have any say in the results.
Just to let you know, I strongly agree.
I do.
Right. And so, yeah, kind of circling back to the previous question. So if I'm hearing a summary of taking into consideration areas of repetition, areas where food safety and worker safety is a very important issue. And then, actually getting to the meat of the application to understand what's going on. And then you can evaluate further with modeling and conceptual, demonstrations. Would that be a good summary?
Yeah, absolutely.
Okay. Well, looks like we have everybody has voted. Let's share the results with everyone, and we'll ask Brandon and Heath to offer some feedback on that. So it looks like a lot of people are pretty comfortable.
Yeah, I can deal with those numbers. I think we got a few to sway still, but hopefully through this progression, or maybe we can contact you guys directly. We can talk about why you feel that you're not comfortable yet. Hopefully we can get you there.
And one of the things that Staübli is fantastic about, from somebody who's had an opportunity to work with other robotic manufacturers, people that are maybe on the fence or not sure if robotics is the right place for them. The simulation that Brandon talked about, the engineering report that they can do is absolutely phenomenal. They can take your layout that either you give us, or we can, talking with you, we can design a layout, send it to them. They can simulate that whole process, from the parts coming down the line or wherever they need to move to, give you a, what robot is the best. You can see it moving in a live fashion, and really give you a cycle time to show that it can be done. Obviously, we would still like to try to replicate it in the real world before it gets put in on your line. But the things that they can do up front to make you feel comfortable and to know that you're going to get an application that's going to work are by far the best things that I've seen come out of the industry in a long time.
Yeah, it takes a lot of the guesswork out of it all, right? I mean, there's so much of it is just, you're expecting some utopian worlds in some cases. So, yeah, it does take a lot of the guesswork out. You know exactly what the path of the robot looks like, and within some wealth of reason, you know exactly how long it'll take to get there. Really, what you have to test is the real world physics of how parts react in real time, to these inertias that they're going to be under. And food is always high speed. I don't think I've been involved with many food applications that are slow. And the slow ones are the easy ones, right? But we like the challenge, so we're okay with that.
Well, I believe this takes us to our next question. Brandon, this one's for you. What are some potential hurdles to adopting robotic automation?
Yeah, so I think I would go back to the aforementioned hygienic design. I think you have to make sure that that everything is designed to be hygienic, not just the robot. That the base, where the controller is kept, the end of arm tooling has to be hygienic. And all the things that I mentioned before about what involves being a hygienic design, the retention areas being cleanable. Do you swap them out and clean them? These are all things that have to be considered during the design process. You don't want to come back to an already working machine and then figure out how you're going to clean it. This needs to be an upfront approach to what we're going to do with this system before we even start picking technical solutions, right? In most cases, what we do on the robot side is we actually require to know what the cleaning process will be, just to sign off on it. We throw out some generic stuff in our manuals. We show a 2 to 12 pH, and we give you some examples of different products that have been used in the past. But in reality, people use different stuff, and not everybody cleans the same way. So I think it's good to make sure to have a list of a process that is followed, and we hope that it's going to be followed within some realm of possibility, right? That it's going to be accurately followed. But if we have this process in place, we can test it. We have a chemical lab in Europe that we use that we send all of our parts to, all of the seals of the robots, all of the castings, all of the flanges, and everything. Every vital part of the robot is tested to make sure it's going to hold up against these chemicals. Then after that, I mean, it may come back that this process may need to be adapted a little bit. Maybe you can't wash it as frequently, or maybe you need to rinse it after you do that certain wash process, because leaving that to dry on there could have some fatal characteristics to it. So you need to have some flexibility to adapt that process if necessary, and you just need to have an open mind to that. And a lot of companies in the U.S. are very unwilling to do that, right? They have something that has been validated, and they don't want to touch it. So as you make the approach to robotics, you may have to present that in an open mind to understand that you may have to make some adjustments to this if possible. But besides the hygienic design stuff, I think the other hurdles that you're going to encounter is the actual application complexity. Like I mentioned before, the food environment is very fast in general. And then the other thing is it's very versatile. It's very, I guess, not consistent. It's not uniform. The parts aren't uniform. The boxes that you're placing into aren't uniform. So you have to have an end-of-arm tooling that can be adapted to a lot of different scenarios. In some plants I've been to, in bakeries, for example, one day you're picking up a biscuit, the next day you're picking up a hot cake of some sort, or some type of pastry, or whatever it is, right? So in the same line does all of those things. So you don't want to have to change every little part of the machine every time you change the line. So having some end-of-arm tooling that can be adaptable to every scenario of your line, maybe a hurdle that has to be crossed over. But in general, I think you have to approach this as the more things you can make uniform, the better, right? You can have one line run one product. It's going to be an easier solution for robotics. If you can have one tray that's being used for your outgoing or incoming, that's something that's going to make it easier for robotics. The way that you display parts to the robot, it needs to be, if we're using vision, or if we're using conveyor tracking, or if we're using some type of flexible feeding system, that we need to be able to have a uniform product and a uniform way of presenting it to the robotic system. So that's where I would start, at least. What do you think, Heath?
I would kind of touch on some of the points that you just said. Absolutely, the product that you're picking up and placing is from an integrator standpoint is crucial to understand. How does it change? Not even from size, but does the room sit at 50 degrees? Is it 30 degrees? Is it 32 degrees? You know, what temper is the product coming down? You know, all those things that can change. You know, you can raise 5 or 10 degrees. You know, maybe you're picking up a sausage patty, you raise 10 degrees, and all of a sudden that sausage patty is a little more melted. You know, then when it's frozen solid, it's going to pick up different. So, you know, a lot of those things are stuff that we like to test on site. You know, here at EnSight, we also work with you know, PIAB, Soft Robotics, and they're very willing to test product for us as well to verify that, you know, we're getting the right vacuum gripper, or maybe we've got the right you know, finger gripper to pick up the product we need. But, you know, from an integrator standpoint, you know, that's definitely one of the things that we worry about seeing when we go out into the field. You know, a lot of times when people call and they have an application, you know, they say, hey, here's what I have going on. They'll send us some video, which is great. You know, if we can, we really want to go out and see the site. You know, we want to look around and see what kind of space you have, which is a huge constraint in the food industry. You know, there's always never enough space. I don't know if I said that right or not, but there's just not enough space. You know, when people come with an application, you know, they say, well, I really want this robot. I've talked to 3 other people, but they don't have anything that'll fit in here. So that's something that we are well aware of, and something we've worked with Staübli very closely to develop. You know, their robot controller. We have a robot controller that sits in the base of the robot, so we can kind of include everything in a small package to fit in a small footprint. You know, if you're only taking the place of 1 or 2 people to do an application, you don't have a lot of room. You know, a lot of times you can squeeze people into a small space. That's usually a large hurdle. You know, understanding what is feasible with the technology. You kind of touched on that before, Brandon. Your robots can do a lot of things, but there's some things they can't do yet. You know, I think in the next 4 or 5 years, it's really going to increase. It always does. But, you know, understanding, you know, maybe we can't automate all of it right now, but we can, you know, do this little portion of it that can help your ROI or can help speed up your production. You know, and really, I guess, you know, our hurdle as an integrator is understanding what the customer wants. You know, we want to spend time with you, understand your needs, you know, and like I said, show us a video, let us come out and look at it. And, you know, maybe there's things that you haven't seen that, you know, that we see all the time since we, you know, we're looking at these applications. You know, the same thing, we always try to communicate with Staübli, the application engineers. We'll send them stuff and they'll ask questions that maybe, you know, we didn't think of. So it's a really great partnership to help overcome some of those hurdles. And then again, probably the last thing to talk about is again the sanitation. You know, you touched on it before, Brandon. You know, with Staübli, you've got a sanitary robot. You know, your stand should be sanitary. You know, everything else in your environment should be a sanitary unit. You know, that's something at EnSight that we take very seriously. All of our design engineers, all of our electrical engineers do a sanitation training through CFS. They partner with us as well, and it's a great training. You know, if you ever think about, you know, the people on 3rd shift that have to clean all the pieces of equipment, you go to the training and you actually have to do that too. You get to put the suit on, you get all the water, and you get to wash it down and be completely drenched in sweat. And it's one of the greatest motivators to design a machine that is washed down and as easily cleanable as possible. So that's definitely one of the hurdles we see in the food industry, but we feel like from our standpoint that we've tried to fix some of that before the customer ever comes to see us. So I think that's all I have on that one.
What about training and training personnel on site to kind of work with the robotics, et cetera?
Brandon, you want to?
Yeah, I can jump on this one.
Absolutely.
For us, I think, you know, we do recommend training to everybody, not just the integrator that's going to be building the machine and obviously programming the robot, but the end user as well has to have some level of comfort to how to operate the system. There's going to be, you know, sometimes some small tweaks that need to be made. You know, and what sometimes happens is, you know, because the robot is the focal point of the machine, if something goes wrong, it's always the robot's fault immediately, right? They look at the robot and they say it's not working, it's not doing what it's supposed to do, it's not moving over there, it's not moving over here, whatever. So something's wrong with the robot. So we get calls and you know, we walk them through some troubleshooting steps, and then it turns out that, you know, a safety door circuit wasn't closed properly or whatever, right? Like, so I think just some general training of what the robot is expecting and under general circumstances is necessary. So we could do some, you know, Staübli offers general training on what we call user training. It's less than a week typically. We do that on site at your facility or in-house at our facility. We have facilities all over North America. So So we have options, but what sometimes is necessary is that you get trained on your specific machine. And maybe Heath is going to touch on that more, but you're going to have to know exactly how your machine is communicating to the robot, what your machine is expecting from the robot to be able to move position A, move to position B, right? There's always going to be sensors, there's always going to be laser scanners or door circuits or something that has to be satisfied before these conditions have to be met before the robot is able to do what it's supposed to do.
Absolutely, and to kind of touch on, training on their specific machine. When we come out, when everything is installed, we stay for 2 or 3 days. It could be a week, depending on your application, the complexity, and things like that. And just go over you with it, have you run it, have it run. Make sure the line's running correctly. We don't want to leave, and as soon as we walk out the door, there's something going on. That goes back to the whole, feeling comfortable with robotics is, feeling comfortable that your integrator and the robotics manufacturer itself is there to help you. And I really feel like we are. We have a team of controls engineers that are always available to take customer calls, to troubleshoot. But we really feel the training on site when we first come in is the key thing. If we can get you to understand, like Brandon said, door switches, sensors, how the robot communicates, how to reset it. If there is an error for some reason, how to deal with some of the product changes. That's something we really believe in, and I think we do a great job with that.
Yep.
All right, thank you all. And I believe that moves us to our next question. So this one's for you, Heath. I know this seems like a softball, but kind of want you to dive in here and be brutally honest. And so what should processors look for in a robotic automation solution provider?
So from my perspective, somebody that understands the food industry, I see a lot of other integrators who do robot integration in the industrial world, and then they're like, oh, I can just do food robot integration. That's easy. It's the same thing as what I'm doing every day. It's not. People need to understand that being able to integrate equipment into the food industry isn't the same as going to a factory that sits at 70 degrees every day and they're making metal parts that get stamped out and are exactly the same. It's the complete opposite. So EnSight's experiences, we've been food equipment manufacturers for 50 years. We've really delved into robot integration as well. So we understand that when we come into a solution, we can provide all the other equipment, where some integrators just will do the robot integration and buy the pieces from somebody else. We can design, build, mock up the whole unit, the whole cell that they're gonna have, bring it and set it in place, and use our 50 years of experience to make sure that you're getting, a sanitary product, which is something, if you don't work in the food industry, I know we've discussed it a lot today, but if you don't work in the food industry, you don't understand that sanitation process. And it only takes one bad, reading or something like that to really knock down your, to shut your plant down. It can be a big daunting task if you're getting product, that isn't made for the food industry. I know, I was bidding on a project the other day. There was a number of other integrators that weren't in the food industry, and the first question they asked was, does it have to be stainless steel? And you just kind of laugh at it. It's like, obviously you don't understand what you're doing. They're not putting it in a wash down environment. They don't know what they need to be doing. So having a partner, a solution provider that understands the food industry, can incorporate that into it. And it goes back to some of the sanitary stuff that we have our engineers go through. I have to really lean on the saying of our VP of operations. She says safety is not proprietary, and we really feel that way. It's not proprietary. Sanitation is for everybody. Food safety is for everybody. We're here to help everybody with that solution as well. So if you're going to find a provider, make sure that they feel the same way about your unit. They're not just there to sell you a robot and then walk away. You're there to make food better, make it safer, for everybody, because we're all the ones eating the food that we're providing. So, Brandon.
Yeah, I think you hit the nail on the head there. I think at the risk of being redundant, I will say that experience in the industry is the key. And it maybe, you need to look at it and fine tune that industry too. So it's not always just food. And for example, it's like I mentioned earlier, it's bakery, it's pizzas, it's biscuits, whatever. Like you can dial down into like some more minute details of things. And if somebody has some experience in that, they're going to be able to call on that and know what they learned from that experience. But the know-how with the hygienic design is paramount. Designing something that can be washed down like we've touched on 100 times there. But I would also go back to somebody who's going to be a good partner. And I think that's important because I think this is not just a machine that you're going to buy and then you're never going to talk to this person again, right? I think inevitably you're partnering with somebody that's going to have a machine running on your floor for the next 10, 15, 20 years, right? And there's going to be all forms of communication is going to have to take place even to get that machine on the floor. And then once that machine's on the floor, it's going to be some experience, some back and forth as we go through this. I mean, from the very beginning, you're going to scope out all the work, and then they're going to add things to the scope, and then you're going to do a proof of concept to make sure that everything works like you expect it to work. Then you're going to have the installation, and then as the installation occurs, there's going to be the inevitable scope creep that always happens that everyone throws their hands up for. Then there's going to be some factory acceptance testing or FATs or PFATs they're going to go well in some ways and not well in other ways, but you need a partner that's going to work through all of these trials with you, and a partner that is partnering with other technology providers like the robot, for example, and the conveyors and otherwise. So they're going to have to lean on their partners to satisfy you as a partner, right? And then once you get that one running smoothly, you're going to want to tackle the next thing, and you're going to want them to use their experience that they learned from working with you throughout this project to tackle the next one. You don't want to have to start this relationship all over again with somebody else because you're going to have to start at the beginning, right? And then after you get that next project running, you're going to want to support the current systems that are out there. You're going to want some service capabilities. You're going to want somebody that is close by to you or can be close in proximity within a certain reasonable amount of time. Somebody that is knowledgeable about their product that can assist. That's going to do some curative or preventative maintenance plan with you, warranty the product with you. And then at some point you may want to revamp the line. After 10, 15 years down the line, I'm not making that product anymore. I want to change this into something else. Obviously, it's going to be easiest for the person who made that line to change it to something else than somebody to come re-engineer what's been done and then figure out how they can make it something else, right? So I think you need to approach it as a very long-term partnership and not just, I'm going to buy a machine in the next 6 months. Who should I choose? If that makes sense at all, yeah.
Absolutely. Brandon, can you talk about too? I don't want to step on your toes or put you on the spot, but I know Staübli has a great customer service team. If they have something down, I know you guys can dispatch people quickly. Do you have any thoughts on that, or could you talk about that at all? Just so people can understand what you guys can do.
Yeah. Absolutely. So for curative maintenance, we try to be anywhere in the country within 24 hours. We have a 24/7 hotline that is available. So if you call us at any time of the day, you're going to get somebody on the phone that's going to be able to answer and troubleshoot with you directly. And then after that, we're going to figure out what parts we need and try to get on site within 24 hours. And then when it comes to we try to avoid the curative maintenance at all possible, right? We try to do what we can with preventative maintenance. So PMs are important. I would say almost more important in the food industry because we need to make sure that everything is operating safely, making sure that everything is operating cleanly. So I would always recommend some preventative maintenance plan to be done at a food factory of some sort, a processing environment. So if we can catch all of these flaws before they actually become a problem, we're never going to have downtime, and downtime is what everyone hates to talk about, right? So yeah, curative planning, curative maintenance, and then the predictive maintenance. And then we also have something that's kind of unique to Staübli. It's a warranty, and the warranty starts with what we typically say is 16 to 18 months for the robot itself as you purchase it. And that gives the integrator some time to develop the solution and then install it. And then typically you have about a year of warranty on the robot after that. But what we do that is different than everybody else is we actually offer to extend that warranty up to 6 years. The only thing that we ask is that we do the PM to make sure that everything checks out. We also do some recordings on the arm to make sure everything's in the green, that we actually analyze these recordings and make sure that the robot's not going to be being overused in any way. And all those recordings check out, we can extend this warranty up to 6 years, which is really putting our money where our mouth is, so to speak. And we're telling you that this robot's going to last in whatever environment you're in, based on, for up to 6 years, which is a large amount of time for a robot in an environment like we're talking about here.
Absolutely. Thanks, Brandon.
Yeah, thank you both. And as a reminder to everyone, you can ask a question in the questions tab of the GoToWebinar toolbar. Just feel free to ask those at any point during the presentation, and then we'll make sure we get to those at the end of the discussion here. And so that brings us to our next question. And Brandon, this is a chance to get really out there, man. What could the future of food processing look like?
Can I talk about like the Terminator scenario, or what are you looking for? I'm just kidding.
Only if he's making hamburger.
Yeah, okay. So I think the need and acceptance of robotics will continue to grow, especially in today's landscape, like Heath mentioned earlier, with COVID-19 out there looming still. People have a larger awareness of the dangers of having people working closely together and the risk of contamination of the product itself, right? You're not just contaminating other people within your factory. You run the risk of contaminating the product that you're producing. But the future is also exciting, right? It's we talk about things like Industry 4.0 or I 4.0 or turning big data into smart data. That's where I see the future really going. And we've talked about preventative maintenances and curative maintenances, but if we can get to a point where we have predictive maintenance, where we can actually predict that something is going to happen based on some trends that we're seeing in the robot cycle, ideal scenario, some utopian scenario would be that if you have everything networked, that your robot supplier or that your integrator can be keeping tabs on your machine at all times, and they start to see a trend, and they can call you up directly and say, hey, I'm seeing some wear on joint 2 of robot 7. Can we make a plan to get out there and sometime in the next couple of weeks, when's your next downtime? Can we come out and check it out? That's where we're heading. And I think all the tools are available today to do this. It's just wrapping them all up in a nice package and making them available to a customer that in a way that they can actually use it. Most IT companies aren't even available to allow us to connect to the robot so that we can gather data like this, right? So that's a challenge that we have to overcome. But the idea of looking at things in real time and understanding what that can present to us, you as an end user and as us as a product supplier, right? As an end user, you can think about, you have these cycle times that you're constantly monitoring, how much product is going through each machine. You can look at optimizing these to fit your need based on order income, based on, orders that are coming, based on your product flow, based on incoming product, raw product, whatever. You can optimize your machine's performances based on this so that you don't have, dead time. So you don't have this bulk product sitting in a freezer waiting on its next availability or whatever, right? So if you can start to optimize things and play with cycle times and play with product tracing and stuff like this, you can really make a good use of all of this big data and turn it into smart data so you can use it intelligibly. What do you think, Heath?
I kind of got two things. AGVs, I think are going to be really big. Automated guided vehicles, especially for the food industry. If you have a room that basically the robots are running the line, you have a vehicle, a fork truck come in, pull pallets out, they can place them, put them other places so they can be easily accessible. They could move into areas where if you had a safety cage or some type of light curtain before where it would have to be muted, stop the robot as the person goes in and pulls it out. The AGV can go in, grab the pallet, pull it out, put a new one in where the robot won't even have to slow down, won't have to skip a beat. I really see that being a big thing coming in the industry. I know on the industrial side, there's already a lot of AGVs that are tending machines. Where they move to different machines, depending on, the line and how they're running. I know food industry, like you said, Brandon, they run really fast. Depending on that, you could have different robots moving to different places to tend machines. You could also have them doing just, spot checking inspections. They go to a line, they're going to pull the product off, inspect it, put it back on the line or put it somewhere else. There's kind of the sky's the limit for that stuff. I think there's a great opportunity there. Then you also don't have people on fork trucks driving around or people driving pallet trucks. You'd have a safe way to transport all your product around your plant. I think we're going to see that, but that also goes along with the plant 4.0, having all that, everything talking to itself so it knows where it's at, it knows where everything else is at, where it needs to go. I really think that's going to be a big thing. One of the ideas that I've heard that I think is a fantastic idea, and I know Staübli is kind of pushing that envelope with the robots they have, but is robotic sanitation. Where the robot is going to clean another robot or it's going to clean a machine. With a robot that's completely, washed down, you can put a hose in its hand, you can give it the chemicals that it needs to spray on the machine. Instead of having a whole third shift full of, 50 or 100 people taking machines apart, spraying it down, they let it sit for a certain amount of time. Maybe they come back in the right amount of time, maybe they don't. You could have a robot, the person comes in, disassembles it, maybe the robot disassembles it, depending on the machine, how complicated it is. But all they would have to do is come through, disassemble the machine, turn the robot on. It could sanitize the machine, wash it down, spray it, be completely done. And you don't have to have that human interaction with the chemicals. So you don't have, issues with chemical burns, chemicals getting in people's eyes. And you could greatly diminish the number of people you would need on a third shift situation. I think it's a great opportunity, especially on the primary side. If you're doing, deboning or something like that, you've got 2 or 3 robots that are, cutting. At the end of the day, they could, you do a change out tool where the robot puts the knife down or whatever it's using to cut with. It picks up a hose, it sprays down the robot next to it, sprays the area down. The robot next to it sprays it down. Then you have clean robots. And you don't have a person in there cleaning, and having to do that type of cleanup as well. Kind of like Brandon, you touched on in the beginning of the webinar, just more movement into the primary side of the food industry. Packaging has kind of been the place where robots have hung out just because of the environment. I think you're going to see a big push for primary side robotics. It's like we said before, it's a cold, wet, dirty environment that a lot of people don't necessarily want to work in. You can put a robot in there that is going to show up every day. It's not going to call in sick, and it's going to do the same job every single day. And also, like I touched on in the beginning, I think as the cost of employment goes up, and the robot technology gets better, the cost comes down. I think you're going to see smaller manufacturers that maybe wouldn't have thought about robotics or any type of automation. I think you're going to see them start to look for that as well to try to recoup some of the cost of that and to be able to manufacture the demand that's out there. I know with COVID-19, just the demand of food, the food industry has just risen to a level that I don't think anybody has probably ever seen. And it's just a matter of time before you're going to have to put robots in there because there's not going to be the manpower to meet the demand that we need, as the world grows. So those are my thoughts on it. I don't know if you have any other comments based on what I said.
No, I think again you hit the nail on the head. That's exactly it. I think AGVs are definitely a fast-growing topic right now. Staübli just purchased a company last year called WFT. They're out of Germany, and that's because we see the growth in AGVs. So now we have AMR solutions where we have robots on top of AGVs moving around, doing some specific tasks at different locations, and that's where you get to some things like you talked about earlier about floor space and making sure that you're not taking up too much floor space. And I've seen lines at food production facilities where they literally, everything's modular. They pull things out and they move things in just so they can make a different product every shift or every hour, right? And if you think of something like an AGV that can just be, that is modular as any modularity can be, right? I mean, that thing can do whatever you want it to do, wherever you want it to do it. It's just some programming away. So, that, or even, maybe you don't do an AGV that is actually moving around on its own, but it's like a cart, like a robot on a cart that is modular in the way that it's on casters and you move it into a position and you lock it down. You teach a frame to the robot and it's back up and operating with a different product or whatever, right? So that's something that we see a trend moving towards, is this like, modularity production, or, more lean manufacturing, where you don't have dedicated lines to certain scenarios, but you're kind of, working a line to whatever your need is. So
I'm glad you kind of said that. I would say we have a customer we're working with right now that is very much interested in that modularity. They have a product that has to be hand packed, just because of the type of product it is. But they also run a different product on that line. So we're trying to develop kind of a robot station that comes up, locks into a carriage, so it's in the same location every time. They can run that product 2 or 3 days a week. Unlatch it, slide your robots out, and then they can put people in there to do that job. Or they could, if they really wanted to, they got to the point, you could put a different type of robot in there if they need it. The other thought is too, with modularity, if you have 2 or 3 or 4, maybe, 4 robots on a line, for some reason one of them goes down, obviously you can't have downtime. You have another robot waiting. You could just slide that robot out, slide the new one in, lock it in place, and then you're back up and running. And then you could do maintenance on that robot, if for some reason it's down. So, there's a great opportunity to kind of fix some of those issues that we've seen in the past with that technology.
Yeah, I've even seen one project that we're working on is actually working with a robot and a person side by side. So we have the ability to have collaborative robots, right? And it depends on what sector you're in, whether or not it's going to be hygienically designed, because as you add collaborative aspects to the arm, if you add cushions and stuff like this, they have to be designed to be hygienic as well. So it depends on what level of collaboration you really need. But we have one scenario where the person will stand right beside the robot as it's packing some product, because some other product that is also coming down the same line cannot be packaged by the robot. So they literally have the person standing right beside them. But we're using some safe functionality, some safe zones, safe stops, safe tool, and we're using all of these functions to make sure that that is safe for that operator to be right next to the robot. And this is something that wasn't available in the past. This is something that just came around in the last few years, and we're getting to a point now where they're at a performance level or a safety level that people are actually starting to pay attention to. So with Staübli, we're at a performance level E for those safety features. So that's something that's starting to garner some interest now, and we're starting to present that as a solution, and people are actually paying attention. So.
Yeah, one of the great things that Staübli has put out with their robots is just like you said, the safety zones that you can use, and just the size of the robots that are using that. A lot of the collaborative robots are pretty small robots that maybe aren't made to pick up heavy loads. But you guys have developed robots. Your standard robots, you developed them with the the safety zone, so they can be set up that way, so you can pick up 30 pound sizes. They have a longer reach. You have a lot more opportunity, I feel like, with your variety of robots that you've brought into the safety world to have that opportunity to use some of that, especially in the food industry. So
yeah. So what I always talk to people whenever they start talking to me about a collaborative application, I was like, okay, first of all, there are no collaborative robots. There's only collaborative applications. So we need to look at the whole application. What kind of end of arm tooling do you look like? Do you have what does the product look like? We had one that the product was actually, I can only describe it as like a ninja star. Literally, it was like a ninja star, and they wanted to move it at a certain speed, and I said, okay, so just without even knowing what kind of robots you want to use, this is not a collaborative application, just by nature of the product. There's too many things that you have to safeguard here. This idea that collaborative robotics exists, yes, it's definitely a good idea. It's something that we need to work towards. But what we've done is we've taken our standard industrial robot arm and made it so that it can be collaborative. You can give it some eyes, you can give it some touch sensitivity, you can give it some different senses that will allow it to react in certain ways. And when we react, we know we are reacting in a very safe way. So that's I guess the mantra that we're trying to go down, instead of making a low speed collaborative arm. And you can imagine, when I talk about collaborative applications, you can imagine this slide rule. And as you become more collaborative, your production will become less producing, right? So as you have more collaboration, your cycle time is going to get bigger, and you're going to be producing less parts. And that's just the nature of the beast, right? Regardless of what robots you use, to be more collaborative, you have to be moving slower. But one thing that we've done is, instead of making a collaborative robot that always moves slow, is we have this industrial robot that has this senses and this ability to work safely, so that you can have it working at a high speed, but then only collaborate when needed, right? When you need to step into the zone, or when you need to have some secondary operation be done, to that application, then you can start working in a collaborative manner, which slows down your throughput, but it gives you that flexibility to do it or not do it, depending on your needs for that given scenario, right?
Absolutely, and it, for everybody that's listening as well. So it's not just industrial applications; they have the same capabilities on their HE models as well, that are washed down. So,
Yep.
Awesome, gentlemen. Well, I believe that takes us to our final polling question. And so, what percentage of your current processing lines could be fitted for robotics in the next 1 to 5 years? 75 to 100%, 50 to 75%, 25 to 50%, or 0 to 25%?
Should we place our bets now?
Go ahead. I'm watching real time, so it's unfair for me.
I'm in the 50 to 75.
All right.
Yeah, I'm going high. I'm going 75 to 100. Maybe it's wishful thinking. I don't know. Hoping for it.
All right, give everybody a couple more seconds. Okay.
Ooh, money.
Yeah, it's
Right.
yeah, it's a pretty wide range there.
Kind
It's
of
like
even.
there's work to do.
Yep. And so any thoughts about how to make that easier, or to think about kind of retrofitting current lines, or is it something to where people have to completely revamp a line, or can they retrofit their current, operations to be more robotics friendly?
I mean, I think there's a lot of opportunity that maybe people don't see, that they could revamp a line without completely replacing everything. Robots are, a lot of times based off vision, encoders, things like that, you can add into the line. Even if you already have a current conveyor, you can add encoders into the line, so you can, understand, the robot knows where to pick from. You can add vision systems. Maybe you have an opportunity where you don't have to replace the whole line. You just need, a portion up front to be able to introduce the product to the robot in a fashion that it can pick it up. So Brandon, do you have any thoughts on that?
Yeah, I agree with what you said. I would also add that maybe this is an opportunity to rethink the way you're doing your line today. Maybe this is an opportunity to make it easier, to make it more optimized for your real need today. I think a lot of lines have been inherited over years and years and years, and they don't change because it's too hard to change them. So maybe this is a good opportunity of, in this predicament that we're in, that people are really cautious of having a lot of people working together and stuff like this. We should rethink maybe the way that we are doing business. And I think a lot of people are doing that. I can see that a lot of people are working remotes. I'm sure a lot of more people are doing WebExes like this instead of going to trade shows and stuff like that. So I mean, we're in this mindset of rethinking things already. And we could probably do the same thing to our line layouts as well, and try to not fall into what has been successful in the past, but also think about what could be even more successful.
So it looks like one of the questions that was thrown up there is, what is the realistic range of number of picks per minute in the food industry with robots? Brandon, do you want to kind of tackle that one, maybe on your side, if you want to touch on that?
Yeah, and it ultimately depends on what you're really doing. But in a nutshell, the food environment is mostly like low payload, high volume stuff, right? You're moving small parts fast into a packaging line or whatever, right? So with our TP80 line, we get realistically somewhere between 150 to 170 parts per minute. We advertise up to 200, and that is real. We have gotten applications up to 200, but that's a very unique scenario. I think realistically, 150 to 170 is achievable. Our standard scare lines can go, up to 100 parts per minute. Our 6-axis lines are somewhere in the 50 to 70 parts per minute. But this is all like, standard cycles, right? And that's assuming that we're picking one part at a time in most cases. So what we do, especially in 6-axis world, is you start looking at picking up multiple parts at a time, and then you can really, pick up your parts throughput just by having the same cycle that was only picking up one part before. Now we're picking up 10, or now we're picking up 12, or whatever it is. And it's not always possible to do, but that's the way you have to think about it and try to work out the different scenarios. Then it's quite common in the food industry to not just have one robot too. It's common to have on one line a series of robots all queuing together, working together to facilitate a throughput on a line. So I have a project right now that's going through that has 11 TP80s working together to make a throughput of 1,200 parts per minute or something like this, right? So it just depends on really what your scenario is. If you have room to accomplish something like that, or if you're looking at robot to robot, what can you accomplish? I would say a max of around 150 is a good ballpark, and then down to 30 parts per minute or something like that for a slow moving high payload application.
Okay. Well, it looks like we are ready for our question and answers period. And so as a reminder to everyone, go ahead and submit your questions in the questions tab of your GoToWebinar toolbar. But one that we have received, what are the cybersecurity risks of integrating more robotics and automation into food processing? That seems to be a pretty hot button topic.
I would say it is. So any type of automation that you can introduce, really does offer cybersecurity risks. The more you network everything together, the more opportunity you can have to have somebody come in and break into your network. They could damage your equipment, so it wouldn't work. You can't produce food, which is obviously a big risk. The Staübli robots and the cells that we make are can be completely standalone. If that's an issue that you have, that they don't have to communicate with anything else. They can be a standalone unit where they're not networked into anything. They wouldn't have the opportunity to be brought in. It builds its own network inside the cell to communicate to the robot and the camera, the other pieces that it needs. Brandon, do you have any kind of thoughts on that?
Yeah, definitely. You can have it be a standalone system, and quite frankly, that's the common scenario, right? Especially today, it's standalone. It's not really networked to anything. If you need to gather data out of it, you've got to go take a laptop and plug into it, and maybe like a PLC or one component of it is networked somewhere, but you're only going to get a small amount of information, and normally that information is one-way traffic. It's only moving out. You can't make changes to it by dialing into it. So I think your risk is low on that point. But that goes back to kind of what we were talking about earlier, is like, what is the future of this? Where do we move from here? I think the future, we start to, having more people willing to open up their network to the machines and the robots specifically, so that we can have more Industry 4.0 discussions. We can have more like big data so that we can turn it into smart data. We'll never get to that utopian world where you get a call saying, predicting some maintenance requirement, right? Unless we can see what's going on, and that's going to require some network connections. So I think as we advance in network security, we're going to have to put protocols in place that will safeguard the system. There's firewalls and there's all kinds of things we can do to make it a safe system. I mean, for every firewall, there's a hacker that's going to be able to get through it, and that's the sad truth of things. But inevitably, we're going to get better and better at this, and hopefully we come to a place where people will stop messing with our food for sure. I mean,
Right.
that should be like an unspoken rule. I mean, don't hack the food systems, right? I mean,
Absolutely.
let's not do that.
One of the things too that EnSight has been offering as we've integrated more robotics lines is we'll use different types of communication. Cozy is one of them that we've used before, but we can set your cell up where it doesn't communicate out. Either by you actually have to plug your network into it to get it to work. We've also done like a keyed system where it doesn't apply any power to the cozy, so it can call out, so we can come in and look at an issue until you have an issue. Maintenance guy has to come out with a key. If they can turn the key on, and then it provides power to the cozy unit, so we can communicate with it and troubleshoot issues remotely. I know that's a big thing, especially with COVID, is trying to troubleshoot remotely where you're not bringing outside people into food plants. That is something we're actively doing and working with our customers to try to adapt with as well, to fit, and to kind of, mitigate some of the cybersecurity risks. So.
Awesome. Well, thank you, Brandon and Heath. I know we're just a little bit over time here, and we want to be mindful of everyone's schedules. And so, just as a reminder, if we did not get to your question, Brandon and/or Heath will follow up with you directly via email. And so you will also be receiving a recording of this webinar as a follow-up with their contact information. And thank you everyone for your time, and have a great day. Thank you, Brandon and Heath.
Thank you everybody for jumping on.
Yeah, thanks for having me.